I have heard of ModelViewController, but prudent properties, never. What exactly is that?
I don't know. Let's kind of go through this diagram and fill it out and find out. So we have MVC. We've heard of that one. So we'll start with the model.
A model, of course, of a cat.
Model, of course, of a cat.
It's
yes.
us.
This is Ozma, our very real cat. She's very pretty.
Typically, you might have a reference back to the model if you were doing things in the view controller which was going to update the model, or if you needed to get data from the model.
What are we going to do instead?
So instead, let's take a reference to the model and pass it in only to an initializer to the view controller. Now, this can't be the real initializer because the view controller is going to be created from Interface Builder, but after the view controller is actually created, it'll be the next step. The prudent properties are not going to be able to be immutable, but...
What are prudent properties?
So the prudent properties are created in that initialization stage, and they're going to be properties that reference the model if necessary, but they are not going to reference the view controller unless necessary. And now the view controller has a reference to the properties, but not the model itself. So we have a layer of indirection where everything knows about exactly what it needs to know about and no more.
So with that in mind, what do we do about testing? How would we test this controller?
This thing we're calling the initializer here will be able to, if necessary for testing, take an object that conforms to a protocol instead of a concrete implementation of a cat, for example. So
we can have a mock cat, like Mayor Ben from Zoobilee Zoo. All right, so we have our model and our controller all set up. So now we're going to put our representation of Ozma,
or any cat,
into the view using our prudent properties. So this is all working pretty well. We have our model, we have our controller with prudent properties, we're telling the view what to display, which right now is just an Ozma. But what if the fairies from Sleeping Beauty come and decide that they want to have a color war with Ozma's fur?
Of course, the view controller can control the view as per usual, but we don't have a reference to the cat anymore in the view controller. However, this prudent property, cat color, does have a reference back to a cat.
I see. So now, make it pink. Ozma's pink. Not only is she pink in the view, she is pink in the model. Now, let's take this back to maybe a more realistic example, converting code from MVVM to MVCpp. What we're looking at is the project from the MVVM talk from RWDevCon by Eric Kearney, but you, Jesse, have converted this to the MVCpp pattern.
Right.
So tell me about what we have here that's different.
First, let's have a look at our PPs. We need 3 prudent properties. We don't actually need to have a user. In realistic usage, this would be dependency injected, and we will be doing that with the tests. But for right now, we do have a user. We won't actually be using it outside of initializing, but let's look at that in a few moments. So we have a password, a protected username, the getter for it, and a username. The biggest difference that you'll see in this file from what Eric had is that instead of having view model dot everywhere, we now have a dot value instead, and it comes as a suffix instead of a prefix. All over a username is password and protected username. Get doesn't need that because it's not a computed property, it's only the getter for a property.
So why do we have dot value?
I don't actually want to have dot value, but we're using computed properties to wrap up a getter and a setter. These are generic objects.
So this is a class that you made.
Right. It's something that I already had, and then it's similar to something that is in the project called box, if you want to check that out also. But I'm not using box anymore. I'll show you what I'm doing instead for binding shortly. So we store a getter, we store a setter, but those are private. How you actually end up using the computed property is via value, which when you get the value, just say dot value, you'll run the getter, get the value that's returned. And then when you run the setter with a new value, then you will assign that using .value equals. I don't want to do that, but there's no way to say that a type is literal convertible to whatever generic you put in. I'd love it if that were possible.
Right, show me how you initialize these prudent properties.
That's going to be done with a function that I'm calling initialize. In ViewDidLoad, really I'd like this to be a real initializer, but because it's a view controller, it's not practical. And all it will need is not actually a user, but what the login view controller considers to be a user.
What is that?
So all that is a combination of a name that can be gotten and set, and a password that can be gotten and set.
Has the user model itself changed at all?
It hasn't. All that we've done is added the conformance of this protocol to it. Right. We knew that user already had a name and a password. That's basically all it's for. So this is really a hack. I don't want to be using a protocol. What I really want to be sending into this initializing function is a package of the getter and setter for a name and a getter and setter for a password, but Swift doesn't have a clean way to do that. We are going to be storing computed properties that act like that, but I don't want to have to be passing them in at initialization time. This is clean enough for my liking given the tools that we have available right now. Also, notice the underscore. I really want this to be a nested protocol, but nested protocols don't exist yet. The initializer's main function is to initialize each prudent property, and each one of them has its own initialization function. Password and username are relatively straightforward. They'll take our protocol, and then they'll return computed properties, which get and set whatever needs to be gotten and set. So in this case, when we initialize password, we're going to get an unknown reference to user. We'll get its password. We'll set its password. And the same thing will happen for username.
What's different about protected username?
Protected username doesn't need to ever be set. It's basically a computed property. We can't create a computed property from an initializer. There's no syntax for that, so we'll just have a function that should be a computed property that is get only. But again, it needs a reference to a user. We'll get an unknown reference to what's passed in. Then we'll get its name and do some logic with that name that's gotten, and then send that back out as a string. And that will have to run as a function. It couldn't just be a function that returns a string, because then it would only work the first time that you use it.
So in Eric's version of start access code timer, he had a reference to self, and I noticed that we don't have that here.
Right. We only need a reference to the code label that a login view controller has, not the entirety of self. So we're going to take only what we actually need in order to be able to do what we need to do. So we will get a weak reference, but it's not to self anymore. It's to the code label. Then we'll return a function which sets its text if it actually exists, and if it doesn't, then we're going to return nil. And then what will happen when start access code timer runs is we'll make sure with this guard statement that we actually have a setter. I hate this.
That's horrible, but I mean, I don't have better, but...
Right, because what we need to do is get a setter. We're going to get the setter for access code, and in order to do that, we need a getter for it, so access code set get.
Oh, man.
But I'm used to seeing this point. If any of you have better ideas about how to express the same thing, please let me know. So once we have a valid access code set, which will happen in the case where code label exists, then we'll run access code set with the generated access code, and then 5 more seconds we'll do the same logic. And so start access code timer, this is what was happening with the box that Eric made, but I don't think we actually need a box. We just need to know what happens when access code is going to be set.
All right, cool. When we went over the diagram, we talked a little bit about testing. I don't think we have anyone from Zoobly Zoo in here, but show me how we're testing this code.
Okay, it's basically the same thing. Because user is so simple, we're not going to bother creating a mock object. We just need something with the name and password, so we'll keep his same the user that he was using, and you'll notice that all the tests are still passing. And similarly to before, where we saw dot value instead of view model, instead of testing the view model, we're going to be testing login view controller directly. The downside of that is that username, password, and its properties can't be private anymore, but that's a drawback of XCTest in my opinion. There's all kinds of times where I want to test something that I really want to be private, but I have to make it internal just for XCTest. It's better than it used to be, where you don't have to have everything be public. I think XCTest should be able to test private things, and nothing else should.
You want XCTest to be like the government and can come in and look at all of your private stuff when no one else is allowed to? XCTest is the police officers that come and confiscate your phone.
Maybe I need to rethink this. But that's how I feel about it right now. But let's look at an example where before we were validating something for a view model. Now we're validating for login view controller directly. You can see that we're checking effectively what is data on user, its password or its username, but again, login view controller has no reference to any user. It only has references to its prudent properties, and they know about a user.
So this was sort of a riff off of MVVM, which to my understanding, the point of it is to improve testability and chop down your massive view controller. Are we accomplishing that here? I think so.
We talk about this a little bit more in the podcast.
Check it out at the link below.